Hi, I'm Amari,
I'm Paul.
and we're here to help you with calculus, finding area between the curves. Okay, so before we start this video, we're just going to show you how to plug these into your graphing calculator. I use my TI-83 calculator. So, this is going to set up fn int, first function minus second function, comma x, comma lower bound, comma upper bound. If you don't know where the fn int is, you got to click the math key, and from there, you click the number 9, and then fn int will show up on your original screen. Again, this y1 is your top function, and this y2 is your lower function. This x, you got to put it there for some reason. This is your lower bound. This is your upper bound. That should help you solve some of these problems in the video. The first problem is an area between the curves problem. Let f and g be the functions given by f of x equals 1/4 plus sine pi x, and g of x equal 4 to the negative x. Let R be the shaded region in the first quadrant enclosed by the y-axis and the graphs of f and g, and let S be the shaded region in the first quadrant enclosed by the graphs of f and g, as shown in the figure above. Find the area of R, find the area of S, find the volume of the solid generated when S is revolved about the horizontal line y equals 1. Before we even start the problem, we're going to find our intersections in the problem. To find your intersections, you have to set f of x equal to g of x. You can plug these two equations into your graphing calculator, and then you get your intersections to be at x equals 0.178 and you get it at x equals 1. Those are the 2 points where the R and S intersect. For A, we have to find the area of R. In order to find the area of this function, you have to set up an integral. Your integral goes between your two bounds, your lower bound and your upper bound. In this problem, your lower bound is at x equals 0, and your upper bound is at x equals 0.178, because that is the intersection. When doing an integral problem, you have to do the upper function minus the lower function. So in this case, it happens to be g of x minus f of x. So you put that into your integral. Always remember to put parentheses around these and end it with dx. Now, when you put this into your graphing calculator, you get your answer of the area of R to be R equals 0.0647. R equals 0.0647. And for this problem, since you don't have any units, you don't need to include units. That was A. Let's move on to B. Now, for B, it's the same concept as A. Instead, this time, we're looking for the area of S. First, you set up your integral. Then, you set up your lower bound and the lower portion of the integral. In this case, it happens to be x equals 0.178. Then, you're going to use the second intersection point to set up your upper bound of your integral, which in this case, it's 1. X equals 1. So just like in the other problem, for this one, we're going to do the area of the top curve minus the area of the bottom curve. And that gives you the area of S. So it's going to be f of x minus g of x. Remember to put parentheses around your problem and tack on your dx. If you did this right and you plug this into your graphing calculator, you should get the area of S to equal 0.410. Remember on your AP exam to always put 3 decimal places, and you don't need units for this problem since no units were mentioned in directions. Next, let's do C. For part C of the problem, the directions read, find the volume of the solid generated when S is revolved about the horizontal line y equals -1. As you can see, we already drew a new figure for you with the horizontal line y equals -1 on the bottom. So, when solving for volume in this kind of problem, we have to use the washer method. The washer method basically means we have to cut it into cross sections which are circles. So the area of a circle is pi r squared. Well, if you're looking for a volume, you have to set up an integral problem with that area problem. So you set up your integral of pi radius 1 squared minus pi radius 2 squared dx. And since pi is a constant, you can just factor it out. So your new integral would be pi, the integral, of course, with lower bounds and upper bounds, of radius 1 squared minus radius 2 squared. Our radius 1 is f of x plus 1 squared, and our radius 2 is g of x plus 1. And you have to square that also. Make sure you put brackets on the outside because you need to put your dx at the end of a problem. So you see, the formula we put on the left side corresponds to the equation we put on the right side, with our first radius being f of x plus 1 and our second radius being g of x plus 1. Now, when you plug this into your graphing utility, you get the final volume of 4.559. Now, let me lower the camera to make this more clear. Well, that was part C. Thanks for watching our video. I'm Amari doing the audio. I'm over here. And my assistant over here, Paul, he's doing all the math. So, thanks for watching. We hope this helped.